In this video, we're going to talk about describing location in a distribution. In particular, we're going to talk about percentiles. When we talk about percentiles, we're really discussing an individual data point in a distribution. So this whole video is about an individual data point in the entire distribution, no matter how small or how large your sample size, your population is. That individual's percentile is referred to the percent of values that are less than that individual's data value. So here is an example of 25 students that took a statistics test that was worth a raw 50 points. And here's the distribution of student scores. So that's the list. Obviously, it's not in numerical order. And here's a dot plot that represents all of the scores. So the lowest being 12 and the highest over here being 48. So if I was to single out this one score of 43, let's figure out what its percentile would be. So what you could do is you add up the number of scores that are less than that 43, and that is 20 scores. So 20 out of a total of 25 is 0.80 or 80%. So we would say that this score, 43 out of 50, is in the 80th percentile. So be aware that when you are describing percentiles, we would say that a score like 43 out of 50 is at the 80th percentile. We wouldn't say it's in the 80th percentile. So let's continue working with those scores on that 50-point statistics test. So remember there are 25 scores. Let's first find the percentile for Jacob, who scored 18 on the test. So you could either use the list or you could use this dot plot and find Jacob's score of 18. And so I add up all the scores that are less than that 18, and there's only one. So that's 1 out of 25, or 0.04, which is 4%, which we would say Jacob scored at the 4th percentile. So now let's work somewhat backwards, and let's work from Maria's test score. So Maria's test score is at the 48th percentile of the distribution. Let's interpret this value in context. What score did Maria earn? So the first thing that I would do here is I would work backwards from this 48th percentile. So that means that it's 48%, which is 0.48 in terms of a decimal. So I'm going to multiply that by the total number of scores that we have, which is 25, and we find 12. That 12 means that Maria scored better than 12 of her peers. So she must be the 13th score, or this 13th dot on our dot plot. So let's try to find what Maria got on her stats test. So I counted 1, 2, 3, 4, 5, all the way up to 12 dots, and that gave me right here. So that means that Maria's score is one of these 4 dots here. So if that's 35, 36, 37, 38. So Maria scored a 38 out of 50 on this stats test. So some other fun facts about percentiles that you should try to stick in your hat here is, first up, calculating percentiles is not an exact science, especially with small data sets. Also, the first quartile is roughly at the 25th percentile, so the median is at the 50th percentile, and the third is at the 75th. Now, keyword being roughly. And also, a high percentile is not always a good thing. Think about in terms of health. What about my dad who has a high cholesterol level in the 90th percentile? I'm making that up. I got that from the book, but my dad does have high cholesterol. Gotta watch that red meat, Fran Iannucci. All right, the aside, keep in mind the context, no matter if you're talking about percentages or anything else in statistics. Context is important. So I hope that we can all agree that percentiles are nifty, neat little nuggets of information, but what more can we do with them? We can make a specific type of graph from percentiles. And before we talk about what that graph is and what it's called and all that good stuff, I want to first look at an example. So we're going to be talking about the first 45 United States presidents and their ages when they first took office. So if we were to organize that data into a frequency table as such, let's say we take their age ranges in 5-year increments, so 40 to 44, 45, 49, etc., all the way up to 70 to 74. And then we took the frequency, so the number of presidents that took office at that age. So on the younger and the oldest ends of our spectrum, we've got 2 and 1, so not super frequent, possible outliers. And then it seems like in the 50s, in their age, not the 1950s, we've got our good chunk of presidents, that's 25 presidents that took office in their 50s. What we're going to do with this frequency table is add 3 more columns. The first being the relative frequency column, which will give us a percent. We'll divide each of these counts by 45, so 2 divided by 45, 7 divided by 45, etc., and multiply each of them by 100 to convert to a percent. Next, we will fill in the cumulative frequency column. So that's going to add up the counts in this column, our frequency column, for the current interval and all intervals with smaller values of that variable. So that means this one would be 2, but then for this one we would add 7 plus 2, making this line 9, and then we would add 13 to that 9, and that would become 22, etc. And then last but not least, and in fact what the graph is going to be named after, spoiler alert, is our cumulative relative frequency column. Say that 10 times fast. You probably do better than I could. Where we divide the entries in the cumulative frequency column, this one, we're going to divide each of those by 45, the total number of presidents, and then we'll multiply that to convert to a percent. So kind of like that, but taking this cumulative notion and creating a relative frequency from that. And here's what this table will look like. So here's the table that we started with age and frequency. Relative frequency, right, we did 2 divided by 45 to turn it into a percentage. So 4.4% of presidents took office between the age range of 40 and 44, etc. And then we add up the frequencies, right? So 2 plus 7 made 9, and then 9 plus 13 made 22, etc., all the way down the line. Then we take these numbers and do that math to it. So we take 2 and divide it by 45. You're going to get the same number because duh. And then we would take 9 here and divide it by 45 and get 20%, etc., down the line until we get 100%, because that means that 100% of the 45 first United States presidents were inaugurated between ages 40 and 74. So, any whoosits, we call that a cumulative relative frequency graph, which I haven't even shown you yet. But this is the reason why I didn't want to just give you the definition, because the definition is very dry. Sorry, definition writer. But a cumulative relative frequency graph plots a point corresponding to the cumulative relative frequency. So not just relative frequency, but the added up relative frequency. So eventually we'd get to 100. In each interval at the smallest value of the next interval. So it means if you're here, it adds up all the intervals that came before it. So you're starting to see how it's related to a percentile. So we start with a point at the height of 0%, because there were 0% of presidents, or at least the first 45, that were under the age of 40 when they were inaugurated. So we start at a height of 0% at the smallest value of the first interval. Consecutive points are then connected with a line segment to form a graph. And fun fact, I've never heard this before, but apparently it's true, that some people refer to cumulative relative frequency graphs as ogives, or actually it's ogives. Weird. Call it that if you want. Yeah. All right, here's the graph as promised. So let's talk about a few things here. So I've written out the points just in case you're listening on like 5 times speed. I don't even know if YouTube does that. But here we go. The leftmost point, as we talked about, is plotted at the height of 0% because there were no presidents under the age of 40 that were inaugurated, to my knowledge. So 40 years is the youngest value. And so the next point is at a height of 4.4%, right? Because that's what we got for our cumulative relative frequency. And that means that the next age is 45, right? So 45 cumulatively is, there are 4.4% of presidents that were inaugurated younger than age 45. So the graph is going to gradually grow till about the 50s. And we looked at that at the very first chart with the frequency and the age, right? The 50s to 60 mark had a lot of presidents being inaugurated, or the most at least in that original table. So it gets steep at the 50s and then it starts to taper off a little bit because there were less presidents being inaugurated after age 60. And the rightmost point over here is going to add up to 100%. That's because as of, recording the first 45 US presidents, none of them were older than 75 when they first took office. And that means, again, that 100% of our United States presidents, at least the first 45, were inaugurated before the age of 75. That's what that means. So let's use this graph and interpret a cumulative relative frequency graph. So let's answer 2 example questions. The first one being, was Barack Obama, number 44, who was inaugurated at age 47, was he unusually young when he was inaugurated? And then the second question is to estimate and interpret the 65th percentile of the distribution. So what on earth is that and what does it mean? So we're going to use this graph to answer both of those questions. All right, so let's talk about number 44, who was inaugurated at age 47. So what I'm going to do with this graph is I'm going to try to find age 47 and then figure out what cumulative relative frequency that ends up aligning with. So if I drew a straight line up from roughly 47, I get roughly, this number over here would be, let's call it 11. So that means that 11% of the first 45 US presidents were younger than Obama when he took office. So I would say Obama was young, but not unusually so. So now we can answer the second part, which is to estimate and interpret the 65th percentile of the distribution. So instead of starting down here on this axis, we're going to start here on the cumulative relative frequency axis. So I'm going to try to find 65 and see where that lines up in terms of age. So I find 65% here, which is this notch, and I draw a straight line over and down, and I'll estimate that at about 58 years. So we would interpret that to be that the 65th percentile is about 58 years old. So about 65% of the first 45 US presidents were younger than 58 when they took office. All right, that's enough president talk from me. That's going to do it for this video. Thanks so much for watching.